go through the active engagement practice activity 2 for one sample t-test step by step with you so that you can check your work with mine and hopefully learn from your mistakes, or to kind of go through the process and make sure that you're understanding all the details. So if you'll notice the research scenario, they are talking about 12 mothers, and they're looking at how important they thought patience was for being a good mother on a scale from -3 to +3, with -3 being not important at all, +3 being very important, and 0 is kind of what we would consider the null. In this case, is just basically neutral, a neutral rating. So they don't really care either way, basically. So if you'll notice, we have here in the research scenario a rating of 0, and that's the mu. We have 12 mothers, and if you notice, that's our sample size, which we can see right here. This is our sample of 12, and if you count how many scores there are 12 scores. We're using alpha 0.05, and nowhere in here is it talking about them looking at them thinking that they were looking at the scores being higher than 0 or lower than 0. It's just they're looking at, if you'll notice, they say, according to the research hypothesis, the null is true if the women rate the importance of patience as significantly different than a rating of 0. So the null is just basically that there will not, or the null is that they will not be significantly different than a rating of 0. Okay. So this should actually, and this I am just noticing a little error in here, as this should say not. That's just the error. So hopefully I can get in there and fix that before everyone completes it. So it should be, important says patient is not significantly different than a rating of 0. So this is suggesting a two-tell test. So this is where I always suggest start writing down what you have, what information you have. So alpha 0.05 two-tell, because they're not looking for a specific direction, and don't infer what you think is going to happen. Base it off of what the research shows. So the first thing that we want to do with this, which is step 1, is write our hypotheses. So we know the null is basically the sample of mothers. So sample of mothers, and we can just basically regurgitate what's up there. Will not rate importance of patience as significantly different than 0. So that means our alternative is that they will. So the sample of mothers will rate, and I'm going to put importance of patients as IOP as different, and I'm just going to put that as an abbreviated version. So that way we have our null and our alternative hypothesis ready, and then we can move on to our step 2. So we know this is two-tell alpha 0.05. So first I'm going to go to the next page, So step 2 is to set our criteria. So since how we see alpha is 0.05 and we're using 2-tail, we're going to go to our table. If you've noticed, I've got this highlighted. So this table, if you notice right up here, I know it's small, is page 529 in your textbook. And you'll notice that this first column or first row here is used for 1-tail, and this is used for 2-tail. So you want to focus on the columns that are underneath 2-tail. So we want to look at 0.05. We don't need to split it. And then we want to look up our degrees of freedom. Since how our sample size is 12, our degrees of freedom is -1, so our degrees of freedom is 11. So if you'll notice, we're going to look at 11 and this column for 0.05, and we get 2.201, this right here. So our step 2 is just reported t critical value equals positive and negative 2.201. So that's all you need for step 2. So if you don't write the positive and negative, as long as you write on there 2-tail and you give me the 2.201, I'm okay with that. Either way, it is just fine. So now we can move to step 3. Look back, our confidence interval was our critical value was 2.201. Step 3 is, and I'm going to put it up here. That is calculating our statistics. So is what you want to do, be really careful when you're entering this stuff into your calculator. You want to make sure you use your negatives. So on my calculator, I actually have a negative button instead of using the minus. So like I put in 1 plus -1 plus 0 plus 0, or I'm sorry, plus 2 plus 3 plus 2 plus -1, right? Plus 0 plus 2 plus 3 plus 2 plus 1. And then before I even hit enter, I usually go through and just kind of make sure that I haven't made any calculation errors. And so then when I enter, I'm getting my sum of x. So I'm going to write that down. Sum of x equals 14. Now we know our sample size equals 12. So we can calculate our sample mean, which is that capital M, which is 14 divided by 12, which you should be getting 1.1666. It keeps going on and on. So I'm reporting that as 1.17 is what I'm reporting that as. Because we want the second decimal and we round it up because 6 is greater than 5, or 5 or greater. How's that? So now we want to go ahead and get our sum of x squared, right? So that means we're going to square each one of these. So again, since how the calculators can be kind of fickle about the way you enter in negatives and squaring, to make sure that they're not holding the negatives, I just drop any negatives. So I do 1 squared plus 1 squared plus 0 squared plus 2 squared plus 3 squared plus 2 squared plus 1 squared plus 0 squared plus 2 squared plus 3 squared plus 2 squared plus 1 squared. And again, before I hit enter, I want to make sure I've entered everything in appropriately. And if you'll notice, I did not enter the negatives in, like for this one, just because if you square a negative, it should be positive, but you have to enter in your calculator a certain way, and that takes a lot of extra steps. So I just drop the negatives because I know it's going to be positive. So it's just a little cheat method for you to be able to kind of work through that. So after you calculate that, you should get your sum of x squared is 38. So these are kind of the basic things that you're going to need to start calculating your t obtained. So next thing we're going to need is our sums of squares. So we're going to put that 38 first. So 38 minus 14 squared divided by 12, right? Because it's the sum of x squared minus sum of x total squared divided by n for sums of squares. And if you plug that in, I always do 38 minus, and then I put parentheses, 14 squared divided by 12, close the parenthesis, and if you'll notice we got 21.6666. It keeps going, but I'm going to report it as 21.67 because I'm rounding to the second decimal. It's often better to keep as many decimals as possible, but when you're writing it down, you can round to the second decimal, but in the calculator, I would keep it at least 4 decimals, rounding appropriately to make sure your data is accurate. So the next step, and I'm going to jump down here, is we want to get our standard deviation for this sample. So we're going to take the sums of square, divide it by degrees of freedom, take that square root. So it ends up being 21.67 divided by 11, right? All under the square root. And so basically is what I ended up with is 1.4035, but you can round it to the second decimal. So 1.40 is the standard deviation. And we're going to use that to get our estimated standard error because our equation is t equals m minus mu, sample mean minus population mean, divided by the estimated standard error. So we need to get our estimated standard error. So we're going to take, I'm going to put it right here, the 1.40 and divide it by the square root of the sample size, which is 12. Okay, and we should be getting 0.405 blah blah blah. So I'm going to put in 0.41. That's what I'm writing down because I'm rounding to the second decimal. But you can keep as many as possible in your calculator just to make it accurate. So now we know what to plug in. So down here in the denominator is 0.41. This is very important that you have your sample mean and your population mean in the right order. I've noticed a lot of people mixing these up, and what it does is it tells us things are going in the opposite direction than they really are. So sample mean should always be first. So we have 1.17 minus 0. Because remember, 0 is our population mean. Mu equals 0. So our t obtained ends up being, when we calculate it, 2.89 is what I'm rounding it to. 2.89. It was like 2.8879, but we'll round it and report it to the second decimal, which is 2.89. So now we need to calculate our effect size. So I always use Cohen's d. So we're going to use the sample mean, because the sample mean minus 0 is 1.17. So I'm going to use the 1.17, but then I'm going to divide it by the actual standard deviation, which is 1.40. Okay, and so that ends up being 0.8357. I'm going to round that to 0.84. Oops. Now we have our Cohen's d. And the last thing we have is our confidence interval. Now it's 95% confidence interval, okay? So let me see something here. I'm gonna bear with me because I'm gonna shrink this down so I can actually write some more on here. Our 95% confidence interval, it is basically our sample mean, okay? So 1.17 plus and minus our critical value for a two-tell test. So since how this is already two-tell, and that's already two-telled, so we don't need to look up anything else. So we're going to put 2.201. I'm going to put parentheses, and then we're going to multiply that by our estimated standard error. So I'm putting in 0.4051 just because I like to do 4 decimals to make it as accurate as possible. So then we're going to get both the lower and the upper. So is what I do in my calculator is I put 1.17, and I always do the lower first, minus, and then I put parenthesis 2.201 times 0.4051, and I close the parenthesis, and you should be getting 0.27837 blah blah, but in actuality we're going to report 2 decimals, so 0.28 comma, and then we're going to do the same thing on the other side, 1.17 plus parenthesis 2.201 times 0.4051, and close that parenthesis. So the upper is 2.06, and then we can close that. Now we have everything we need basically to determine whether our test is significant or not, right? So the way that we can do that, so if you recall, bear with me one moment again, I'm going to squeeze this down even further. If you recall, originally, our critical values for two-tell were negative 2.201 and positive 2.201. So anything that falls beyond there is significant, okay? So there's 2 different ways that we can determine this. And in actuality, you shouldn't be just using one. In reality, you should be using both, and they should coincide with one another. So that's why we do the confidence interval, to see, like, okay, are we really significant? So we take this 2.89, it's positive, so we know it fell way over here. So this is where we know it's significant, because in this area it's not significant. Anything on the outsides is significant. And this is significant, telling us that our 12 mothers rated the importance of patience as significantly higher than 0. So this really makes sense. If we were to say it was on this other end over here, it would be saying that they rated it as significantly less important than 0, which is the opposite meaning of what it really is. So there's one way of saying it's significant. The other thing that we should look at is kind of look at it on a number line. Okay, so our null hypothesis is saying that our population mean would be 0, and that if it's not significant, we would see 0 as within the range of numbers between the lowest and the upper. Well, 0.28 is a positive number, and it's over here, right? So 0.28. And then the upper, that's the lower range. The upper range is 2.06, which is way over here, 2.06. So 0 doesn't fall in between. So the null was not within that range of numbers. So this does show significance because 0 fell outside of the range of parameters. So we know that this analysis is significant. This confirms our critical and obtained t comparison within the distribution. It's just another way of confirming the information. So now we can move to step 4, which is writing our results, because we have all the information we need. So we're going to go to an empty, and I'm going to put this as step 4. And this is a very important step because it has to be written in a specific format. So I'm just going to kind of base this off of what our null and alternative hypothesis was. So the sample of mothers rated the importance of patience as significantly, I'm just going to put sig, greater, because it was higher than the expected 0 as t degrees of freedom is 11 and the t obtained was 2.89. P was less than 0.05, because remember, if it's out in the tails, it's less than the alpha. It was a two-tailed test. So even though it was two-tailed, I do like, if it is significant, I like to state like which direction it went in, because it helps us to make sense of things. Two-tailed with, we're going to report our Cohen's d equals 0.84, and our 95% confidence interval was 0.28, which is the lower, and 2.06 as the upper. Hopefully this helped to walk through the steps on this analysis. Please don't hesitate to send me messages or email or see me during my office hours for more help, or if there's some area that you're not sure how I obtained the information, or you need further description. But here's your APA statement. Hopefully this helps. Please let me know if you have any questions.